LlamaExtract is a fully managed service from LlamaIndex that offers structured data extraction from complex, unstructured files. We can either specify the structure ourselves, or LlamaExtract can infer the data structure itself from some initial data. LlamaExtract has a lot of use cases. One of the prominent one being metadata extraction and filtering based on the extracted metadata. LlamaIndex already has a vector index auto-retriever that uses the LLM to automatically create metadata filters based on the user query. And now that we have LlamaExtract, we can take it a step further and automate the entire process of extracting the metadata from the documents and also generate and apply those metadata filters based on the user query. So here's the high-level overview of the system. First, we specify the structure of the metadata to extract. Then we use llama parse on those complex files to get the parsed documents. And we use llama extracts to get the metadata for each of those documents. And next, we zip them together to get the list of documents with their associated metadata. Then we create a vector store index using those documents. In our tutorial, we used Chroma as the vector store because it supports metadata-based filtering. And in the next step, what we do is we use the schema of the metadata to be extracted and then convert them to a list of metadata info for each of the metadata that we extracted. This metadata info is used by the vector index auto-retriever, and the language model will use this metadata info later for automatically generating metadata filters. Now we use the vector index and the vector store info to create a vector index auto-retriever. This special type of retriever takes a user query and based on the user query uses the LLM and the metadata info that we pass to it in order to automatically generate a list of metadata filters that will be applied during retrieval to get the relevant list of nodes. Now let's look at the code. First, we need to sign into LlamaIndex and get an API key. And we need to put that API key in the .env file. So next what we do is we create a Pydantic class specifying all the metadata that we would need to extract from the documents. In this example, the files are a list of resumes, and these are the metadata that we would like to extract from each of those resumes. And now we import the LlamaExtract library, and this is how we create a schema. So the create schema function takes in a name for the schema and also the JSON schema to extract. And we use the schema function of Pydantic model, which returns the JSON schema for this model. And if we run this and go to extraction, we can see that there's a new schema has been created on LlamaExtract. We can see that there is an ID associated with it. We can use this ID to get the schema from LlamaExtract. So the ID is what we're going to use every time we would want to use this schema. For example, if we want to update the schema, first, for example, we would want to add another field called professional summary about the candidate's personal experience. So first we need to update the Pydantic model itself, run the code, and we need to update the schema, passing in the ID of the schema that we need to update, and also the updated JSON schema, which we can get using the schema function of the Pydantic model. And if we run the code, we can see that this schema has just been updated. So after that, we specify all the resume files and we run the extractor by calling the extract method, passing in the ID of the schema, the files, and the response model. So the response model will make sure that it returns two results. One of them, the all metadata and all metadata models. All metadata will be the list of metadata in dictionary formats, and all metadata models will parse those dictionary into this Pydantic model. So that's how we got the metadata. Now we need to get the documents themselves. For this, we're going to use llama parse. And while instantiating llama parse, we will pass this argument split by base equals to false. So for each of this file, we get one document. By that, we'll be able to properly tag the document with its metadata, which is exactly what we're going to do now. We zip the documents and the metadata together and assign the metadata field of each document with the metadata that we get from LlamaExtract. Now, if you look at the metadata for each of those documents, we can see that LlamaExtract extracted all those information from those resume files. Now we need to create the vector store index. For this, we're using Chroma because it supports metadata-based filtering. So the index creation process is quite trivial. We pass in the documents to the vector store index.fromDocuments function and pass in the storage context as well, where we specify which vector store to use. In our case, it's going to be Chroma. So after creating the index, now we create the vector index auto-retriever, which takes in the index that we created and some vector store information, which basically contains the information about all the metadata we have, which is later used by the LLM to automatically create the metadata filters based on the user query. So now to create the metadata information, we use the metadata pydantic model. We go over each of the fields, and for each field, we create one metadata info instance. Now, after running that, we can see that for each of those metadata field, we have the name of the metadata field, the type, and also a brief description. This entire thing will be used the LLM during retrieval to automatically create the metadata filters. So we put all that info into a vector store info and we instantiate the vector index auto retriever, passing in the index and the vector store info. And then we create a query engine using that retriever. And now, if we run a query, for example, what degree does the candidate in Maryland have and from what university? So we can see that it's using this query string and the filter it automatically created based on the metadata info that the state should be Maryland. And this is the response that we get. And this was obviously for demonstration a very simple example, but the sky's the limit on what you can do with all the extracted information you get from LlamaExtract. So for demonstration, it was a quite simple example, but definitely in real world, the schema is going to be quite complex and also very complicated metadata filters as well. And LlamaExtract under the hood uses Llama parse to parse the complex document. So it supports a wide range of file formats and complexity. So I think that this is going to be really useful in extracting information from the documents and filtering based on that information extracted and automating the entire process. Thank you very much.